Academy. He's a career space officer with assignments in operations, acquisition, research and development, and academia. He's commanded operational space units at the squadron, group, and wing levels. The general is also an Olmsted Scholar, graduate of the Senior Acquisition course, Level 3 Certified Program Manager, and 1998 graduate of ACSC. Prior to his current assignment, General Thompson was the Director of Plans and Policy, U.S. Strategic Command, Offutt Air Force Base, Nebraska. General Thompson currently serves as the Vice Commander, Air Force Base Command, Peterson Air Force Base, Colorado. He assists the commander in organizing, training, equipping, and maintaining mission-ready space and cyberspace forces, and providing missile warning, positioning, navigation and timing, communications and cyber capabilities for North American Aerospace Defense Command, U.S. Strategic Command, and other functional and geographic combatant commands. The command oversees Air Force network operations, manages a global network of satellite command and control, communications, missile warning, and space launch facilities, and is responsible for space system development and acquisition. The command comprises approximately 38,000 space and cyberspace professionals assigned to 134 locations worldwide. Let's welcome to the ACSC stage, Major General Thompson.
Thanks, everybody. Good morning. Please take your seats. All right, it's a pleasure to be with all of you here this morning for the next hour or so to talk about, we're going to start by talking about space and cyber, and after that we'll talk about anything that you all want to talk about. You heard a little bit of my bio, but more importantly, a little bit about the command that I represent here this morning. First of all, our commander, General J. Raymond, is the commander of Air Force Space Command, and actually I'm filling in his shoes here this morning. The good news about being the vice commander is I have one boss. It's a 4-star, General Raymond. The bad news about being the commander is he has about 540 bosses. He's got the Chief of Staff, the Secretary of the Air Force, the the Secretary of Defense, the Chairman, and then about 535 bosses up on Capitol Hill who all think they own him as well. And so one of the reasons he can't be here today is because he's trying to solve all those bosses, and so I get to be here instead. As discussed a little bit in the intro, Air Force Space Command, I'm not going to give you an organizational brief here today. Air Force Space Command organizes and trains and equips space and cyber forces for the United States Air Force. On the space side, we've got a numbered Air Force, 14th Air Force, that's also, whose commander is dual-hatted as a joint functional component commander for space, and does joint space operations for U.S. Strategic Command and interfaces with geographic combatant commands for those space capabilities. We also own the acquisition arm for space systems in the United States Air Force Space and Missile Systems Center. That's unique in terms of the way the Air Force is organized, having operational and acquisition responsibilities for that specific domain. On the cyber side as well, we've got a numbered Air Force, 24th Air Force, that operates our networks, that defends our networks and provides other forces to U.S. Cyber Command for offensive capabilities and other things. A little bit unique in that sense, it's not just 24th Air Force that provides cyber forces for the United States Air Force to U.S. Cyber Command. It partners with 25th Air Force. 25th Air Force is actually an ACC. They cover primarily the intelligence aspects of those cyber operations and support, and 24th and 25th work together to do that. That's all I'm going to say organizationally. Really what I want to say today is it is an exciting time to be in space and cyberspace in the U.S. Air Force and in the Department of Defense. Been in space for 32 years, and I've probably never seen a time when there's so great of a challenge and an opportunity and an incentive to move forward in this particular domain in this mission area. And as always, it's really focused on the fact that there's a threat that we face today that we haven't faced in the past that we have to address. On the cyber side, we've really been after this now hard for about, in an operational sense, for approaching a decade, and are again on the verge of taking the next steps there. So for all of you out there, regardless of the nation you serve, regardless of the service you're in, regardless of your domain expertise, your weapon system, whatever it is you do in the military of your nation, whether it's the United States or somebody else, you should care about space and cyber. You should know a little bit. You don't have to be an expert, but you should know a little bit about it. You should understand how it contributes to joint and combined operations. And you should at least be smart enough to know, as you're doing whatever it is, whether it's tactically, operationally, strategic planning operations, to make sure you've got somebody in the room, somebody thinking, and somebody helping you to sort through capabilities, effects, vulnerabilities that space and cyberspace bring, and how the capabilities they have should be integrated into joint operations. Okay, so in the context of making sure we understand that, let me give you a historical example. This is the 70th anniversary of the United States Air Force. Let's talk about where the Air Force was in air, in space, and in cyber at its birth back in 1947. 1947, just 2 years out of World War II, the statement of air power in World War II, it was being integrated tactically, but it was really strategic air power. It was the 8th Air Force in Europe. It was the 20th Air Force in the Pacific. And basically, at the end of World War II in 1945, day in and day out, the Army Air Forces, the strategic forces of the Air Forces of the United States, could put 1,000 planes over a target somewhere in the continent of Europe every single day. 1,000 airplanes, range of about 1,200 miles. Bomb load at that range of about 3 tons, which meant, depending on how the loadout occurred, anywhere from about 6 to 12 bombs per airplane. All of them focused on one single aim point on a target somewhere in Europe. They did all their mission planning with paper and pencil. They navigated by dead reckoning, typically with some wind correction. The communications they had inter-airplane, and really back with any command and control node, was very rudimentary. It probably didn't exist at all once they got out of line of sight range of their air bases. They planned for one target. They planned for a backup target if they got the right information from weather, which was modeled, or by a weather observation airplane that led the bomber train. Perhaps en route they made a decision to divert to a different target. And history tells us that at the close of the war, when they did the United States Strategic Bombing Survey, the probability was that 6,000 to 12,000 bombs from 1,000 airplanes, the probability was that 100 of those bombs would fall within 1/2 mile of the aim point. 100 bombs within a 1/2 mile. Now, that had great strategic effect. It was the state of the art in those days, but that was what air power was in 1947. 1945 it had advanced beyond that, but 1947. On the space side, in 1947, there was nothing in space except naturally occurring objects, asteroids, comets, moons, etc., etc. However, in 1946, the RAND Corporation had written a paper that described the potential utility of a world-circling spaceship. And they forecast and they talked about all the things it might provide to a civil society, commercial market, military capability. And it really did form the basis for the Department of Defense, and that time mostly the Air Force, as to where we should go, what we should do, and what we should expect in space. Now, it took us a good 15 years. It wasn't really, we started with ballistic missile capability. It wasn't really until about the end of the 1950s that we started launching satellites. They really didn't have military utility in the early 1960s. But in 1946, we saw and we understood and had a vision for where we could go in space. Computers in 1947, there were 5. They weighed 26 tons. They were the size of a house. They consumed 170 kilowatts of power. And they computed at the fantastic rate of 5,000 computations per second. That was where we were in cyberspace in 1947. In fact, 5 years later, who was at the time the president of IBM International Business Machines said, there were 5 at the time, he said there was probably a worldwide demand for about 5 more of those computers. That's where we were in cyberspace at the dawn of the United States Air Force. So let's talk about what has happened 70 years later, and let's use as an example the B-2 raid in Libya in January of this year. 2 B-2 bombers took off from Whiteman Air Force Base. On the way to the target and back, refueled by air 15 times. We don't even really talk about the range of strategic bombers or even air power anymore. We talk about the limit of the endurance of the crews that are on those airplanes. We don't really talk about them in terms of range anymore. Those two B-2s had done all of their mission planning. They had received their targeting information, intel development from ground, air, and space-based platforms that identified a total of 108 targets. They planned for strikes on 108 different targets. En route to Libya, they received target updates on at least 50 of those targets, either adjusting the specific aim points or changing the targets entirely. Weather forecasting that had been done on exquisite models that were computer-based models that had decades of data, and space-based observation so that they knew the weather en route. It wasn't just a forecast, it was real-time weather reporting. All of the communications that occurred that wasn't intra-airplane occurred via satellite on the way. And for those 108 bombs that were dropped on 108 different targets, to the best of our ability to measure, every single one of those bombs hit exactly on target. So in 1947, it took 1,000 airplanes to get 100 bombs within a half mile of the aim point. In 2017, 2 airplanes with 108 bombs dropped and hit 108 separate targets. That's a statement of how far the United States Air Force has come in 70 years. And if you talk about and think about how we got there, if you think about what the Air Force was as an Air Force in 1947 and its vision for the future, you could absolutely see to 2017 and what the capability was. If you thought about what the Air Force could be as a space force in 1947 looking into the future, with that paper written by Rand, you could see where the Air Force could be and how it might apply that capability in the future. In cyberspace, however, it's a totally different story. In 1947, the vision for cyberspace was, we can see a use for about 10 of these things in the world. Even in 1982, the Air Force had the vision to create Air Force Space Command 35 years ago because it saw the need to exploit the space domain with a purpose-built Air Force organization to do that. In 1982, National Geographic, of all magazines, wrote an article about the magnificent microchip, which it foresaw could someday mean a computer in every single house. And even that was not nearly visionary enough, because even in 1982, nobody foresaw something like this and the capability it brings in the computer sense. And so, for 70 years in air and space, we've seen, and we keep moving toward the future. In cyberspace, the difference is we have no idea where we're going to be in 35 or 70 years in cyberspace, even though we could probably forecast and foresee where we'll be in air and space. So that's where we've come and where we are today. And a lot of that very much has to do not just with the vision and the innovation and the energy and the drive and the passion of America's airmen, but it is also because of what space and cyber bring to us. And that's only going to multiply and manifold itself increasingly in the future as air power progresses through the next 70 years. A lot of what happens is going to happen because of the capabilities we bring in space and cyber as well as what we bring in the air. But now let's talk about the challenges that we face in those two domains, cyberspace and space. Next slide, please. Cyberspace is different as an operating domain because in addition to operating in and fighting in cyberspace, humans build and operate the domain in addition to operating in it and fighting in it. Other than that, however, there's no reason we can't and shouldn't and do not treat it like an operational domain, just as we do land, air, sea, maritime, and space. The difference is, however, what I'll call the cacophony of activity that occurs in the cyberspace domain every minute of every single day. And what you see up here on the chart is that capture in 2016 of the level of activity that occurs on the internet every single minute. And in amongst that cacophony of activity are armed forces, both ours and our coalition partners, conducting operations and activities that we need to do to support national security and commander objectives every day. But in and among that cacophony of activity as well are a multitude of malactors who either purposely, because they have national objectives, purposely because they have personal objectives, purposely just because they've got to spare a couple of hours and want to see what they can screw around with, or sometimes just through sheer bad fortune and mistake, have the potential to pose a threat and cause harm to the Air Force, our armed forces, our coalition partners, and their allies. And in all this cacophony of activity, our cyber warfighters have to see, sense, understand, recognize where those threats are, where they're coming from, and either protect us from them, as in not allow them to penetrate, but defend in the case that they do. Next slide, please. And so in amongst that activity, when you look at where we are in terms of the cyberspace domain today, it grew up historically really with a mission support and a functional mindset, right? Cyberspace domain grew out of, first of all, communications, and what I'll call the administrative aspects of computer networks. The focus was, give me my email, give me my radios, give me my telephones, make sure I can communicate, and the job was just to make sure it's there when it's needed. The transition, however, has occurred because when you think about that B2 example, when you think about those mission planning systems, when you think about the automated flight software systems on our modern aircraft, industrial control systems, you think about how tightly now all those aspects of cyberspace have been interwoven into every weapon system and every system that supports them. It is no longer just a mission support activity. A bad actor with the right access and bad intentions can have a military and national security effect on those systems simply by the application of cyberspace power. And so that domain and that culture and that group of folks who grew up just figuring out how to provide communication support, how to keep your computers running, now has to think less about that and has to start thinking about where are the vulnerabilities in all these systems, what's the potential if somebody exploits those vulnerabilities, how can they gain access, and how can they apply them, and what can we do to stop all of that activity. And so that's what the focus now has to be in the cyberspace domain, even as we build, architect, operate that domain. We have to think about how to make it secure. We think about how to defend it, protect it, and make sure that that domain and the systems in that domain operate through all phases of conflict. Not where we've been in the Air Force today. And so, especially for those of you that have been in the Air Force, understand your communication squadrons out there in the wings primarily worry about, do you get email? Do you have your cell phone working? Do you have all those sorts of things? We can't do that anymore. Today, we probably have more airmen in the United States Air Force worried about whether I can get unclassified email on my phone, and I can make phone calls on my phone, and I can get to the internet on my phone, than they are worried about whether or not the maintenance system that supports F-16s is up and operating, whether or not the mission planning systems for the B-2 are open and vulnerable to attack, whether or not the satellite control network that flies every one of the 70-plus critical satellites Air Force Space Command flies every day, has an insider threat or is open. We have more cyber airmen in the Air Force today worried about my unclassified email and my cell phone than we do worried about those things. And that is absolutely upside down in terms of where we are today based on the threat, based on the criticality of those other systems, and what we have to do to make sure they're secure. And so where we are today in cyberspace in the Air Force is a transition that says comm squadrons are no longer a mission support function. Comm officers and airmen are no longer mission support forces. They now need to be operators, and they need to be integrated into multi-domain operations in an offensive sense and in a defensive sense. Now, given the position we're in today in the Air Force, we are not, that's mission growth, but we are not going to get more airmen to go after those missions. So what we have to do is execute a transition of the roles and responsibilities and functions of those airmen. Because, let me take a quick poll if I can. All of you get government email, Air Force email, whatever it is your service, your nation email is. And probably most, if not all of you, also have email service at home. Many of you in previous jobs or current jobs have had cell phone and other service provided by the Air Force as well as your own. Just a quick informal poll. Raise your hand if your government or Air Force email service is as good or better than that you buy and get at home every single day. Yeah, just what I thought. A couple. Now, so where we need to go in cyberspace, that's commodity IT and that's commodity network services. There are companies and people in the United States and around the world who know how to do this very well, who can provide those capabilities very well, who we can trust to protect our unclassified data just as well as they protect personal information, banking information, retail information across the world every day. So what we as an Air Force need to do is outsource that commodity IT and network service activity that is routine and available so that we can take our young airmen who really aren't really intended to do that sort of thing and repurpose them to understanding our critical infrastructure, whether it's industrial control systems, whether it's logistics and maintenance system for aircraft, whether it's fuel delivery system, whether it's a logistics system, whether it's that satellite command and control network. Understand it, live on it, operate on it, and look for, hunt for bad actors and defend against them. So that's where we have to go and where we are going in that regard. And that's the challenge we face, is a transition in the Air Force to do that. Next slide, please. Similarly, we face something of an analogous challenge in space. 32 years in the United States Air Force, 32 years in space. I've lived over here for the most of my career, right? Space is a relatively benign environment. Space is a peaceful sanctuary, right? No weaponization, no militarization of space. That was at least the idea. It's still the idea for many today, but that's what people thought. In reality, since the earliest days of our exploitation of that domain, it has been militarized. We've used it for national security and military purposes since we entered space back in the late 1950s. That was why we pursued space capabilities, and our adversaries back then pursued space capabilities. It's simply the fact that there was no good and effective way to threaten these capabilities in space that meant, for much of my career and before that, we just worried about how well our space capabilities performed, whether or not they would operate effectively in a relatively peaceful domain for decades, how to get that information to the folks that needed it, and what we needed to do if, in fact, a spacecraft on orbit had a problem. Never once thinking about, was there an adversary out there? What capabilities do they have? How might they threaten my system? What am I supposed to do to fight through in the advance that they do come after my space system? Well, all of that has changed in the last 10 years. sort of the watershed event, although it had been occurring before that. The watershed event was 2007 when the Chinese tested against one of their obsolete weather spacecraft a direct ascent, kinetic kill anti-satellite weapon. They demonstrated in 2007. Since then, they've expanded that repertoire not just to threaten satellites in low Earth orbit, but all the way out to geosynchronous orbit, which means every single orbital regime we operate in for military purpose, they can now threaten our space systems. They have expanded their order of battery, their magazine depth, so that they're now approaching the ability, not just in terms of capability, but capacity to threaten all those systems. They've also been experimenting with and developing on-orbit systems that might have the ability to affect, disrupt, degrade, deny, destroy our spacecraft. And the Russians, who in the past had had similar capabilities, have now started down the same path. And so we are absolutely no longer have the luxury of saying, I've got this space capability, it's a great capability, I'm going to tune it to the peak of performance, I'm going to provide all the data that I need to the rest of the joint force, but I don't have to worry about what threats there might be, what adversary threats might be, or how to operate. In other words, I didn't have to think like a warfighter, like warfighters in every other domain have thought for decades and or centuries. That has all changed. And so the transformation now that we're going through in space, not just in the Air Force, but the rest of the joint force, is to start acting like warfighters, just like every other warfighter in every other domain has for a long time. Next slide, please. And we have a lot of work to do in that regard. The first is to create a vision and an architecture that actually has the ability to fight through conflict, to understand what the threat is, to understand what our vulnerabilities are, to develop systems and capabilities and train warfighters and develop tactics, techniques, and procedures to be able to succeed and prevail in a war should it extend to space. Now, let me be the first to say, and you will hear all of our national leaders say correctly, we do not want to see a war extend to space. Certainly, war has consequences, tragic consequences in many cases in every domain. But when it comes to space, there are particular physical and operational aspects of the space environment. That means, should a kinetic war extend to space, the consequences for the United States military, commercial, civil society, and basically globally in general, those consequences will be felt for sure for decades and likely for centuries. Because of the physical nature of the domain, if you destroy objects in space, the remains of that destruction, remains of that object, will remain orbiting the Earth for a long time. The Chinese ASAT test in 2007 instantly created at least 1,500 pieces of new debris. Subsequently, we cataloged a total of 3,000 pieces of debris. That object was destroyed at 800 miles in altitude. 98% of the pieces of debris that were created by that test in 2007 remain in orbit today. And because of the physical nature of the domain, the fact that they're traveling at the speed of 17,000 miles an hour, every one of those pieces poses a potential threat to any active orbiting spacecraft they might come in contact with. That's the nature of the consequence of a war that would extend to space. Expend that idea to every single orbital regime, and that's the potential consequence. And so that's why the first thing we want is to deter a war in space. And to do that, as you do in all other domains, the best and most effective means of deterrence is to demonstrate to a potential adversary they will not achieve their objectives should they carry that war to space. And so as a result, you now have to develop an architecture with an entire sensing network that not just tracks all of those objects in space, as we do today. We track about 23,000 objects orbiting in space today. About 1,400 of them are actually active satellites, ours, theirs, gray space. but we track 23,000 objects, but we just count them and catalog them. What we need to do is surveil the space domain like we do all other domains, understand what the capabilities are, who has them, which of those capabilities present a potential threat, where they are, what indications and warnings might exist that they're about to conduct adverse action, and then be prepared to respond should they do that. Our space surveillance network is not set up to do that. Our command and control structure is not set up to do that. We don't have the intel expertise in space to do that. All of that has to be built almost from the ground up so that we can understand what's going on there. We've got to take these capabilities, we've got to train on these capabilities, we have to exercise these capabilities, we have to build TTPs for these capabilities. All of that, again, has happened in decades in other domains, has not yet happened in space. And then finally, we have to do it on time scales that we have never done in the past. Today, just about 2 months ago, General Raymond approved the vision for the next block of GPS satellites. The first one of those will be launched in 2025. Understand, we've been flying GPS satellites for decades. We got 30 of them on orbit today. The fundamentals of that satellite remain the same. A couple updates to technology, a couple of new features, and still it's going to take us 7 years to finish the design and build and fly that satellite. We can't do that on that scale anymore. We also can't do it at the cost we used to. We've got to get much more agile in terms of what we do in acquiring and flying and then ultimately replacing the spacecraft. And then the last piece of that is coalitions. What you all know and have experienced through your careers, and we learned for decades before in every other domain, is the only thing worse than fighting in a coalition is fighting alone. For years, the Air Force and the U.S. culture in space has been, these things are so special, the capabilities they have so unique and exquisite that we cannot share them with anybody else. While that fact and that reality has long since moved on, many of our allies, many of our adversaries have capabilities in space as good or better. Our culture and our mindset that says this is closely held stuff we have to protect, we can't share even with our best allies, has got to move by the wayside, and we got to build stronger and more effective partnerships, just as we have for decades in the air, in the maritime domain, on land, and with our special operations forces. And all of those things, for most of you, you probably look at and say, duh, that's what you do as a warfighter. So for better or worse, this is all new to space operators, which is really to adopt the culture, to adopt the mindset, to adopt the processes and the approach that will make us successful in creating a warfighting culture and mindset in space. So that's where we have to go in space. So let's talk a little bit about the challenges. You can either go to the next slide or you can take down the slides and take a bit of the slides. So let's talk a little bit about the challenges associated with it. The first for both space and cyber is people. On the cyber side, the first challenge is recruiting, training, and retaining the type of cyber expertise we need for a couple of reasons. One is, let's just say in general, the mindset and the culture and the predisposition to those who are very effective operators in the cyber domain today does not lend itself to military service. A lot of them, it's the old, in the basement, probably has a ponytail, probably hadn't been to the gym in, maybe their whole life, and then a little bit of an anti-authoritarian. That is typically, that's the stereotypical model of what a cyberspace operator. Of course, there are many others who meet that what we would call that prototype of what we would want in a military officer, but there are a lot or not. But even those that may not meet the standards we think we need for military members, they still want to serve. And what we need to do is find effective ways to let those people serve. And frankly, I'll tell you right now, we're having a lot of discussions with the Guard and the Reserves and other models for how we might secure and use that cyber expertise. It's interesting, It's interesting. I mean, there are still those today, especially in places like Seattle, Washington, and Northern California, when you see airmen in the Air Guard drive up for their weekend duty in a Porsche, because there are those that want to serve. But that's another challenge we have is we can't afford. There's such a demand for that cyber expertise, and it comes at such a high cost. Oftentimes, we can't afford to pay those cyber airmen what they might get outside, and or once we've trained them, we can't keep them. So there's a challenge there as well, is how do we, once we recruit them, if we have, how do we train them? And then the third piece of that challenge is training. The standard Air Force model for training does not apply effectively to cyber airmen. You know, if you think about how, if you're an Air Force pilot, think about that training model that turns you in to the outstanding aviator that you are today. If you're a space operator, think about the model that was used to make you that space operator today. If you're an intelligence expert, think about that training model. At the end of the day, that's a 20th century industrial age training model, but it still works relatively effectively for those weapon systems, because people that join the Air Force or other militaries don't have a whole lot of capability as an aviator, as an intelligence officer, as a space operator, and you can assume the gap between what somebody might know coming in and what they need to be an effective Air Force officer in one of those areas is so great, you can apply a similar training model to everybody. Now try to apply that training model to somebody who comes in to join our cyberspace forces. Perhaps that individual in high school built their own computer as well as the computer for their entire family. Maybe they managed the networks for their high school. Maybe in college they had a computer science or computer engineering degree. Might have been in a cyber club that built and attacked and defended networks as part of their activities. And then you're going to bring that person in the Air Force, sit them down at cyber training day one and say, this is a computer. That's not, first of all, there are people who will be like that, but that's not going to work, because the expertise and the knowledge that some of these folks come into is close to, and in many cases may exceed, the capabilities we already expect them to have in the cyber domain. And what we need to focus on are the military or the Air Force aspects of that cyber training, rather than walking them all the way back to square one and day one and telling them this is a computer. But you have to create a training model that assesses every single one of those folks, decides where they are, and modifies and adapts their training program to make them at the end that single what we expect out of a cyber professional coming out as training. So those are the kind of the people challenges we face in cyber. In space, I've kind of touched on it already. It's really a cultural challenge. People like me who have grown up our space career operating in a relatively benign environment, don't have to think about threats, don't understand what it means to be part of a joint warfighting team. Two things have to happen. Either people like me have to age out and move on, or we've got to change and get with the program. The good news is the young folks out there, especially people like you and younger that are space operators, get it, understand, and increasingly understand what they need to do to be part of a joint team. The second challenge we have is resources. Not surprising. That's the challenge of the Air Force today. When the chief was here, I don't know if he said this in specific words, but I'm sure he said it in terms of what he, the message he was communicating. The United States Air Force is smaller today than our nation expects it to be, but is larger than its budget can afford. That's not just true in space. That's not just true in cyber. As you all know and you've seen firsthand, that's true in every aspect of the Air Force today. The combat air forces are almost on their butt. The reason they are not is because of the energetic, innovative, and courageous airmen of the United States Air Force. The resources we have not given the CAF for decades mean it is not the force that it needs to be. Same is true in the mobility forces, same is true in the special operations forces, same is true in space and cyber. We have got to find a way to either decide as a nation that we're going to resource the Air Force we need, or we need to change our priorities and our perspective on what the Air Force would be. Right now, in order to create, as we talked about, there's a whole new mission set in cyber. Defend and protect, as well as offensive capabilities. We still have to do all of those mission support related cyber things we've done for decades, but we've got to grow into this new mission set. We're not going to have more people. We don't necessarily need more people. We just need to transition those people. But in order to do so, we need to have the resources to outsource that commodity activity and networks services activity that our airmen perform today so that they can focus on that. And then on the space side, to build an entirely new architecture that not only continues to do the missions that we've done every single day, but incorporates things like threat warning receivers, countermeasures, maneuver capability, as well as the infrastructure and other capabilities on board and off board to defend and protect, is going to take additional resources. And so that's the second biggest challenge. The second challenge we have in each of these air forces is resources. And then the third and the last is we simply don't have coherent policy and strategy in space or cyberspace as a nation. We really don't. A couple of examples. What's the terminology and red lines that we believe we face in each of these areas? A couple of rhetorical questions. A couple of years ago, North Korea conducted a cyber attack on Sony. Was that an attack on the nation? Were there national security implications to that? The Chinese continue. They have for years. They continue to exfil tremendous amount of intellectual property and other information from clear defense contractors and private companies, and sometimes they are able to penetrate our military networks. Is that an attack? What's the appropriate response? And then, of course, there's a whole discussion of what the Russians did in the context of our last presidential election. Is that an attack? Is it not an attack? What's the appropriate response? What should we say to the nation and the world about how we treat those activities? We have to have that. We have to turn that from an argument into a discussion and ultimately a set of national policies that support it. How do you deter in space and cyberspace? Is one satellite approaching another consistent with space norms? We know how to conduct a safe intercept in international airspace, whether it's the Russians and their Bear bombers in Alaska or the U.S. and its strategic reconnaissance operations in a whole host of countries. We know what aircraft encountering each other, intercepting each other in international airspace looks like. We know what it looks like in the maritime domain when potentially combatant ships encounter each other. What's expected, safe activity in those close quarters, what isn't? We have none of that in terms of policy or even discussion in the space sense as to what constitutes a safe confluence of spacecraft, what includes a safe, expected, normal intercept, and what doesn't. What's a red line in terms of attacking space systems on orbit? Is a red line an attack on any satellite? Is it a destructive attack? Is it a non-destructive attack? Is it a red line if they attack a nuclear command and control satellite? Is it a red line if they attack a GPS satellite? None of that policy associated with that, or a strategy that says, here's how we're going to treat those sorts of activities and their reflection in national security, really exists in a coherent fashion today. So those are the three kind of challenges that you have really in space and cyber: people-related, resource-related, and then policy and strategy. The good news is I know the answer to all these challenges. I know all of the things that we have to do in space and cyber. To some may look daunting, all the challenges we have. But I know the answer to those challenges, because it's the same answer that we have used for decades, and that is the energy, the creativity, and the innovation of the minds of the U.S. military. That's why you're here this year. That's what you're going to do for us in the future, not just you as leaders, but all of those soldiers, sailors, airmen, Marines, who for centuries have seen problems and challenges similar and have solved them for the nation. I know you all, both for the United States and for the countries you represent, will be a key part of solving these and other challenges we have in the future. Thanks all for your time this morning. I think we have time for a few questions.